I don't know what it is. Streaming from this other computer, it connects the first time every time so far. I don't have any of the hangups I used to have with that other one. Interesting. Who would have thought? Howdy, y'all. We're getting going. Excellent. I'm just getting set up. As it says, stream will begin soon. Make sure you submit your questions. Oh, nope, there goes. I'm just testing the delay. I'm just testing the delay. I'm just not much of one. Okay, y'all. I am going to go grab some coffee. Give y'all a moment to submit questions. We'll go through how to submit questions when I get back. Yeah. So I'm gonna mute up and block the camera for just a second, or yeah, turn off the camera for just a second. And I'll be back in just a minute. All right, math friends. I don't know what to call viewers. Well, viewers, but I don't know, something more friendly. God, I hope my chair is kind of squeaky. I hope that does not come up. I need to listen. A thing I really don't want to do, y'all. Is watch my streams in their entirety. It's very hard. I need to go through and clip out clips and things like that. And that will happen eventually. Right now, we're just working on doing it. Just working on doing it, figuring out content, figuring out how it feels, getting myself used to just sitting down and doing this on a regular basis, getting myself used to being on camera, managing the stream. I still need to get myself set up with like OBS or some other streaming software. It'll almost certainly probably be OBS. I used something when I was using Linux before and was back when I was thinking about this. This has been in the works for like 2 years. It's just an idea I've had. We're 10 minutes in though, and that seems like a good point to say hi. I'm Ryan, the calculus tutor. I'm here to answer your math questions. Probably like math homework questions or questions as you prepare for quizzes or tests in a math class you're taking. But honestly, questions, math questions from anywhere in your life, or just questions about school and your experience of school and how to navigate school, things like that. I've been a classroom teacher, but I've also been a high school student, an undergrad student. Um, so I've not only have I had those experiences, but I've also had the experiences of being a teacher um, in those settings. So yeah, if you have questions, um, please ask. How might you go about doing that? Well, let's hold on. I want to show you, but oh, I need to change my banner that says Monday through Thursdays and Sundays. It's actually Tuesdays through Thursdays and Sundays. Okay, well, let me fix this, and then we'll talk about how you submit questions. So this is the Tuesday night stream. I have stopped streaming on Mondays for the time being. So this is the first stream since the Sunday stream. And I got to tell you, I think I'm really glad that I am not streaming on Mondays. It actually is just really, really great for my schedule and other things. So it was, I think, the right decision for me. All right. So now, if you would like to submit a question for me to answer, All right. So if you would like to submit a question and have your question answered, you can go to thecalculustutor.com. How am I doing this now? Sorry, I mentioned briefly at the top that I have changed my setup. Um, in order to show you this now, I have to use this screen, and that's just a little bit different. Um, hmm. Okay, I apologize. My computer is uh, giving me just a little bit of there we go. Okay. There we go. So if you go to thecalculustutor.com, this is what you should see. Uh, as you can see, the stream is here. This is sort of your one-stop shop. If you want to participate in chat, you'll have to click on through. I'm still looking into ways to like embed the chat and make a single page that's a really good streaming page. But yeah, if you and I do encourage you to participate in chat, so you can click on through and watch the stream on YouTube itself. To submit a question though, there is a can you yes, you can see my cursor. Okay, yeah. There's a submit a question button right there. You can click, give it a little tap a tap. It'll take you down here. And then here's the button to the homework submission form. Here, I'll let it load. Yeah, homework submission form. Or you can just email your questions directly to me, Ryan at thecalculustutor.com. So same domain, and just me at thecalculustutor.com. I encourage you to use the homework submission form. If you click that button, this is likely what you will see, though it may pop up a sign into your Google account page first. So it might want you to sign into your Google account. Uh, you can submit images through this form, and anytime you set up a form so that people can submit files, they have to sign in with their Google account to access that form. So that's why you have to do that. Um, Try to sign in with your school account if that's your preferred account. If you have your own personal Google account, that would be fine too. Um, yeah. If you do try to sign in with your school account, so you try to sign in, and then it says you can't access it. There is a possibility that just means your school has your Google account locked down in such a way that you can't access forms, or at least forms that allow file submission, um, outside of your school network. If that's the case, please email me your question. I'll get it just the same. Include in your email that you couldn't access the form. And if you think of it, include your school district, and I will try to reach out to your school district and see if I can do anything to make my form accessible to you. I might just be able to. I might just need to have the form put on like a whitelist or something. But anyway, my hope though is that this shouldn't give you any trouble. You'll just sign in. You should be able to access it, and then if we go through this, you just have to check the box and say yes, this is my email address, my Google account. Go ahead and include, or yet this is the email address associated with my Google account. Go ahead and include it. Um, Then tell me who you are. This doesn't have to be your real name. This can just be whatever. Because when I go to answer your question, I'm gonna be like, oh, this question is submitted by such and such. So tell me who is such and such. Uh, this would be a fine place to include your pronouns as well if you care. If you don't include pronouns, I'll probably just use they. Easy enough. So yeah, let me know how you want me to refer to you um, when I answer your question. Really quickly, let me also know where the question came from. This, honestly, my thinking here is this can be as simple as the teacher in the class, right? So, Mrs. Jacobson's Algebra 2, right? Mix Brocky's Geostats, whatever. Very simple. If it's not from a class, if it's just sort of from your life or from something else, from your work, if you're a parent or just not even currently a student that found your way here and you have a math question, please submit it. In that, where did this come from? Just generally tell me how you came upon this math question. It doesn't just like barely even one sentence, right? Or as much as you want. And then finally, we can get to like the actual important bit here. Uh, oh, notice this already has stuff in it. Um, Sorry, let me turn this down. There we go. This is where you ask your actual question. Now, my thinking here is not that you will like retype the entire question, especially because it'd be really hard to reproduce like equations, like math type here. So my thinking here is that you would put like, um, you know, number 10, and then down here you would attach a picture of problem number 10. However, the key with this, with what is your question, it's not just to tell me which problem number. Um, it's also this be as specific as possible. Um, so yes, tell me number 10. Yes, include a picture of number 10. But what I would also request is that you tell me what about number 10 is giving you trouble. Sort of direct me, right? Because I can just go through the problem from beginning to end, and I probably, that's likely what I will do. But if I know what you're struggling with in the problem, I can focus more there or talk about strategies at that part or something like that. So, as an example, right, you could put like number 10, I get stuck at the factoring step. Boom. Right? You don't have to tell me where the factoring step comes in, any of that. If I look at the problem, I will probably understand why you were factoring or where in the process you had to factor. And so when I get to that part, I can sort of pause there and I can talk a little bit more about factoring. Um, and so yeah, this giving me just a little bit more, one, maybe two sentences, just helps let me know what are you actually asking about. Now, sometimes it's not even that, right? Sometimes you don't even feel like you can get into the problem. Sometimes you feel like, I don't even know uh how, there we go, to start uh this type. I don't even know how to start this type of problem. That might seem almost like a cop out or something. Like it's not even worth saying because like I'm sending you the problem. Obviously, I don't know how to do it. But no, telling me you don't even know how to start is actually specific. You're telling me the part of the problem you need the most help with, at least right now, is the beginning. And that's a very reasonable place to be stuck. So yeah, give me one or two sentences there. Um, and even if as specific as you can be is, I'm not sure how to do this type of problem, and that could be like, so if you could tell me like, we didn't go over this type of problem in class, that is actually kind of specific. I'll tell you a little bit more about what to include in that case in just a second here. So yeah, the problem you'd like me to focus on and one or maybe two sentences about specifically what about that problem is giving you trouble. Then the other important bit to this whole process is you attaching an image of that problem, and that makes it so you don't have to retype that problem, right? You don't have to worry about how you would include the math equations if there's wonky notation or anything like that. You can just take a picture of it, which means I guess I would recommend doing this, filling out this form on your phone probably, so you can just take a picture and then hit add file, and it's just right there in your camera roll. Um, that seems like it'd be really easy. The other thing though is if you these are problems on like Canva or WebWork or MyOpenMath or just whatever, some electronic, if it's some sort of online math homework, um, just take a screenshot. Take a screenshot and make sure that screenshot gets saved so that you can actually attach it. If it's a PDF, if the problem you're working on is inside of a PDF, you could just take a screenshot and that's totally fine. But you could also just attach the entire PDF. So you can attach images or you can include images or PDFs on this form. Um, and so that might make it even easy. If you include an entire PDF, it's probably even more important that you're specific about specifically what question and specifically what part of it you want help with. Um, when you send your pictures, the goal is to be clear and complete. So clear just means the text, mostly the text and all the numbers are legible. So just double check. And I'll do my best to if it's a little bit blurry, but I can still more or less make out what it says, that'll totally be fine. And if I can mostly make it out, but there's like one or two numbers that are just like, I'm like, I cannot tell if that's a 3 or an 8. One, hopefully you can just pop into chat and clarify. But if you're submitting a question, but you're going to watch the VOD and you're not planning to be like get the answer live or whatever, um, that's totally fine. I'll just end up making an assumption. I'll just say I'm going to call it an 8, and we'll solve the problem as if it's an 8. And if it was really a 3, hopefully me going through the problem shows you how the steps and things to take, and you can change it to a 3, and that'd be a good practice for you. Anyway, clear just means I can read it. Complete means don't accidentally crop out part of the problem. That sometimes happens. But the other part of complete means if there are like a separate block of instructions for that problem, make sure those are either included in your picture or make sure you take a separate picture and attach that as well. Same thing with any diagrams or charts or anything like that. Including like sometimes with like graphing problems, they'll give you a little coordinate axis, right? And they'll want you to graph it on the provided coordinate axis. If you include that in your picture, I can include that in my notes and I can do the problem right on the same exact little coordinate axis you're expected to do it on. And that, I don't know, I feel like that just helps bring the whole thing together a little bit more. If I can be working on the same type of thing you are and demonstrating how your teacher might expect you to communicate your answer as well. Um, and then the only other thing is it could be useful for me if you include an image of any work you've already done on that problem or any relevant notes you took from class or any similar problems that you worked on. Um, don't It doesn't have to be a ton. Just one additional picture of work you've done that is relevant to that problem um, could be really useful for me to answer your question because I might be able to see from your work where your misunderstanding is. Um, my promise to you is that if you send me a picture of your work, it will not show up on stream. It'll just be for me to look at as I'm ingesting the problem you've sent. Um, just for me to look at and go, oh, I see. This student, you know, you know, seems to be making this sort of mistake, or oh, I can see from this the student has this sort of assumption, and I can just address that. Um, you can see that there is this checkbox. Yes, you may share images I submit of my work on this problem. My thinking here is especially like older, like college university students, they might actually want me to go through their work and actually like say, look at line by line, especially on like longer problems. That can be really, really helpful. Um, but do not feel obligated to check that box. That's there in case the question you're asking can really only be answered by me going through the work you send in, right? If and so again, my thinking there is this is probably going to be for college or university students in like higher level math, potentially calculus students in high school. That's about the level the in high school where that might be a useful thing. But yeah, so please send me your work. It is really helpful if you also include a picture of your work. That's helpful to me to giving you a really good answer. But don't feel obligated. Uh, Nothing in this form is meant to be a barrier. So please, if anything uh, is making you feel like you can't submit a question because of something, one, reach out to me, just tell me that, but ignore that part. Just ignore it. Just do what you can and submit your question. I will do I will do my absolute best to just move towards you and take whatever you have been able to submit and give you the best possible answer. So yeah, this is just you know all the stuff you could do to give me all the stuff I might need. Um, if we go back to my website, so like I said, you can email me your questions. Um, but when you email, it's not a bunch of separate boxes. It's just one big blank message thing. So here is what to include in your email to get a good answer. This is a way to ask the good question. But these are the same things in the form. Your name, i.e., what you'd prefer, how you want me to refer to you when I answer your question, including your pronouns if you care, where the problem came from, teacher and class, your specific question, and then clear and complete images. Simple as that. Um, I think that does it for us for the for that sort of stuff. We'll get this shared again. So, with that in mind, let's check and see if anybody has submitted any questions. And if not, I know what we'll be doing tonight. Uh, the form, I should be able to see if you submitted a question via the form um, within seconds. I should receive that within seconds. Um, Granted, I may not know that you submitted it within seconds. So, like, if it's been a couple minutes and I haven't acknowledged that I received your question, um, just ping me in chat. Just say, "Hey, I submitted a question. Has it come in yet?" Um, because I don't have any sort of way to get like moment to moment alerts. Um, but I should be able to see when things come in if I'm checking the right windows. So if I've just been away from those windows for a minute, just ping me and I can check them again. I'm not seeing any questions. Oh, glasses. All right. So tonight, what I think we will do. Can I? Nice. Okay, cool. Um, what I would like to do today, um, while they're in between submitted questions, is begin an ongoing project. This is the OpenStax calculus textbook. This is volume 1 of that calculus textbook. There's actually 2 volumes of it. OpenStax here is open source textbooks and educational resources. I really like the there's elements of the website that are clunky, um, but I really like their textbook. Um, I like it as a reference, um, and I'm curious about it as a learning resource for somebody that was trying to use it to supplement a calculus class they're in, or self-study calculus, either learn calculus on their own just by going through the textbook, or learn it. Maybe they took calculus and dropped it, and they're just trying to get a leg up over the summer so that when they take it again in the fall, it goes really well, or something like that, right? Um, so I wanted to go through this textbook, and I there's a few different ways we could do this. Um, One way is to actually go through this sort of section by section, kind of reading it and things like that. And I'm not super interested in that. I think I'm mostly going to skim because I've already read this. It's that nice dream, right? I'm not even actually tired, but just sitting here at the computer, not doing much. Just makes me yawn. So I think initially, how I'm gonna initially approach this is, yeah, I'm gonna sort of skim. Um, but what I will definitely do, where my skim will slow down, is answering all of the questions. Um, because my thinking is I want to see what the questions are, and then knowing how textbooks and things are organized, um, the answers should proceed where the questions are pretty closely. And so try answer all the questions, and what I hope to build out of this, what I hope to be creating and have, say I go through the entire first volume or I go through both volumes, but um just for each chapter and each section, have a recorded copy of somebody answering that question, and but using, not just providing an answer, but uh explaining, like solving, providing a solution to that question, right? So it might be referencing back in within the textbook itself and say, oh, this question is answered right up here, here's the answer, boom, right? And showing, not just what the answer is but where it comes from, and then obviously things where there are mathematical steps that can be shown, they will be shown. I will show them. And so my hope is at the end of this to then have a catalog of supplemental companion material to this textbook of somebody teaching the solutions for people who are using this textbook as a resource. This can be sort of a companion to that. You have a question, you're unsure about how to solve any of the questions in there. Boom, there's a video along with work from me showing how to get that solution, like where it comes from. Now, granted, there's still going to be things that, like, I'll explain that may leave a viewer with a question, and because it's a video, they can't ask that question and get clarification. But my hope is I'll make these, and then people will use them and find them and see them, and any questions they do have, hopefully wherever they found these, it's super easy to see. Like if they find them on YouTube, or they do a Google search and they find them on my website, they have a question about one of those answers, they can submit it and I will answer it on stream, and then I'll have a little bit more material to supplement to that. Or a new updated solution to that question where I clarify or correct. Maybe I made a mistake, right? I misstated something. Um, Whatever. That sort of small stuff happens. So anyway, my hope is that this can be sort of an ongoing and sort of a spiraling thing. Um, One, it lets me focus on calculus, which is where I like to focus. That said, please ask me literally any math question you would like some help answering. That you are, uh, you know, either you would want somebody to help you learn how to answer it, or you just want somebody to double check your answer, or you're not even sure where to start. Any of that stuff. So, oh, is there a third? There's a third volume to this. Guess I just didn't even really realize that. I almost never have students who are taking um any. Well, that's not true. Some of these topics get covered in some calculus classes that students I do have, but by the time students are really, really getting into this level of stuff, um, I think a lot of times they just don't even think of a tutor because, like, you would need somebody to. So you're just going to ask your professors or you're going to ask your peers. Um, a lot of times, when you're doing this level of math, you already have sort of a support group around you for that. Um, anyway, they have a third volume. Great. Um, so yeah, we're going to start at volume one. Derivative calculus. My hope too with this, I'm starting behind the school year, but I'm going to move through this faster than the calculus classes are. So I will catch up to where the calculus, if I do this consistently, and plan to, I plan for this to kind of be one of the main things I do on stream going forward, interspersed with other things, and obviously interspersed with answering actual submitted questions. My hope is that ends up taking most of the time, and so maybe this project ends up getting backburnered, but that's fine. Um, but yeah, this so I will eventually catch up to where excuse me, the high school calculus classes are, and then pass them. Um, but also, well, a lot of the high school calculus students, at least the ones who are struggling, um, are still probably a little bit rusty on some of these topics, and so starting there and going through them now would actually potentially provide a lot of clarification for those students. Honestly, not just the ones that are struggling. I've met very few calculus students who are, as they are learning it, super confident about it. It's just so different. Not so different, but it's just different from a lot of the other stuff you've been learning up to that point. And so even the most confident math student, and I mean that was me in high school. Like I took calculus as a junior and dropped it. Took it again as a senior, so I could, and I was taking it with some of my actual like grade level peers. Whereas when I took it as a junior, there were no grade level peers with me. Um, and yeah, and I dropped it, and then as a senior too. I don't think I dropped it a senior in high school, but I don't. I remember not liking it and not feeling I was good at it and not really understanding it. Calculus didn't click for me until I took it in college, um, during my first year of college. So yeah, if you find yourself in calculus and it's not quite clicking, you feel like you're struggling with it, that's okay. Calculus is tough. It's different from other math that you've done up to this point. Ask questions. Try to dig into what your misunderstandings are. Follow your curiosity. Like really look at what do you understand? What are you curious about that you're learning? That sort of stuff. Okay, so yeah, we are. I don't think these are links. They're not, but they are links over here. Um, okay. The So there are things there's elements I do really like about this textbook. I do actually really like it as a reference. Um, because it is really specific, but just reading through it now, like just we're in the very, very first section and we're just already defining, it's just very mathy. But it is a calculus class, so I guess you sort of assume that people learning this have been dealing and learning some very specific math vocabulary really recently. Um, yeah, okay. So this is starting with like a review of functions because ultimately calculus is a process we do. Calculus is a process. The calculus tools of derivatives and integrals are things we do to functions. Um, okay. Ba, ba, ba. Okay. So the examples, right? They have a solution. So I'm not going to do those. I'm going to let those stand on their own. But then the checkpoint, right? And the checkpoints are always questions similar to the examples. And I think every time there's an example, there's a checkpoint question that follows it. So they're like, here's this type of question, and here's how to do it. So here's this type of question. Now you do it, right? The very, very basic, standard sort of textbook process there. Um, Here, give me one sec. Oops. My nose is running, so I'm gonna mute this and blow my nose. All right, I'm back. Hi. Um, all right. So, very first example in the book, example 1.1 is about evaluating functions. Checkpoint 1.1 is about evaluating functions. We have a function here, and it says to evaluate, and it gives us two different things to evaluate. Uh, Similar to here, notice this one also includes this a plus h thing. So that's a thing that they want you to be able to do for some reason. Um, so what I would like to do then, okay, so I want to, I want to try to keep this organized, but I'm definitely going to end up changing my formatting and stuff a little bit as the process goes on, as I realize what I actually need. Right? So I guess I shouldn't worry about this too much. So I think what I will do is, I guess I can get rid of that because the stream has actually begun, of course. Okay, so I can label this. Let's see. So we're gonna do, this is gonna be OpenStax Calculus Volume 1. Okay. That seems good to me. This just sort of labels it, what we're working on. Oh, I guess I will put in chat. Um, I guess I can just keep mentioning it throughout the um, stream. Go to the calculustutor.com to submit questions if you'd like me to, if you have a math question you'd like me to answer. If you would like to follow along, if you would like, because as I'm going to go through this, right, I'm going to scroll, and you're only going to be able to see what I'm currently showing, but it might be useful for you to see what I've scrolled past. Um, and so one, you can definitely hop into chat and say, hey, can you slow down for a second? Absolutely, please do that. But at the same time, I know it can be useful to be able to go back and look whenever you want, and not have to like do chat, which is always going to lag behind a little bit, right? Um, and so I want you to have the ability to uh, navigate these notes. And so if you do go to the calculustutor.com, ba, 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 that pink box where the stream appears. Here, let me share this. Oh, I need to. There we go. So if you go here, there's a button here, go to notes, and that will go to the, right now it will go to the current set of notes, the one that I'm currently working on in the stream. These are going to get archived because I'm not just going to keep working on the same document forever, right? It will, this Miro board, as the board gets fuller and fuller, it gets slower and slower. It starts to like lag and get jittery and stuff. So I eventually will archive these. So I will need to have a place for the archive to be available. I'm working on that. There will be a place on the website on the calculustutor.com. But for right now, if you're trying to follow along in the current notes, or you want to access something from the current notes, that's where you go. Is use that go to notes button, and it will just jump you straight into this. You can't. It's read only from your end, but you can go wherever you want and look at whatever you want. So that's really nice. And then you can also actually, if you click on my face in the upper right hand corner of the Miro board. So let me go back to the Miro board. There we go. My face up here in the upper right, if you click on that, it will bring you right to me and it will follow along. But then you can, at any point, you can just scroll away and it'll break the follow. But yeah, so if you're trying to find where I'm at, boom, click on me, it'll jump you straight to me. Then from there, you can drag it and say, go back up to the previous part of the problem or something like that. So yeah, just wanted to let you know. All right, so OpenStax Calculus Volume 1. So as we go through this, okay. Sorry, I got caught up in reading through some of the text. Um, so what my plan is to grab, say, these checkpoints. And put them in here, and we can just use the textbook content itself as sort of our little dividers. And now I can go through here and we can just talk about how we would do this. And as needed, I will refer back to the textbook and pull stuff from the textbook into the Miro board. So yeah, so first things first, our sort of action word here is evaluate. So to evaluate, when you're asked to evaluate, it means find the output value of a function for the given input value. All right, so this light blue, these are definitions, things that could be useful in your notes. I don't necessarily recommend you write down every single thing in your own notes, but if, I will definitely define words and stuff in that. Evaluate just means plug the x value into the function, right? And functions are just these named equations essentially, right? This equation is named f. It takes one input, almost pretty much all the functions you're going to be dealing with in calculus take one input, and by default, we call that input x. But we could literally call it anything we want other than a number, right? Because 2, 3, 5, 1, 9, those symbols all have inherent value, concrete value, whereas x, we don't know what its value is, so it can be a generic placeholder. And that's all it is. It says this function named f, it only has one input, and then the equal sign says is basically like, here's what you do with that input. Here's what this function for any particular value of x is figured out. You take that input value, you square it. You take that input value, you multiply it by 3, and you subtract it from the square. And then finally, you add 5 to whatever the result of that is. And then boom, now you have an output value, a y value, a function value. Those all mean the same thing. So yeah, we're just literally going to plug values in for this x value. So for instance, f of 1, and actually let me, f of 1 is going to equal 1 squared minus 3 times 1 plus 5. 1 squared is 1, 3 times 1 is 3, 1 minus 3 is negative 2, plus 5 is positive 3. And so we have evaluated this function f for the x value 1 and found out that the function value is 3. Another way to say this is f of 1 equals 3. F of 1 equals 3 is how we'd say that out loud. Or f of 1, this of phrasing is just sort of the phrasing we use for it's sort of the language version of these parentheses, right? If whatever your function is named, it's that function of whatever your input value is. So g of 6, but you can. This doesn't happen in math very much. It happens a little bit though, but it happens way more in computer science where functions have longer names than just one letter, right? I could have my own function, named Ryan of, X, and it does something with X, right? Boom. And so I could plug whatever I want into that. I could say, oops, of 3, right? And this is Ryan of 3, or Ryan at an input value of 3, the value of Ryan when the input is 3, Ryan of 3. But yeah, so this is our answer for that first part. F of 1 is equal to 3, simply because that's what happens when you plug 1 in for the x value in this function. Evaluate. They also wanted, though, f of a plus h. So this might seem tricky because these aren't numbers and there's a plus sign in here. So there's like math inside the function. This is all okay. And in fact, what we did for the last one is exactly what we do for this one. And this is generally good advice in math. Just because something looks more complicated doesn't necessarily mean that the process is more complicated. It doesn't necessarily mean that the things you already understand are invalid. And it's good that they're having people going through this textbook practices at this point. This is a big part of calculus, plugging non-numerical things. Or I don't want to say non-numerical, but non-numerical values into functions. Plugging, say, functions into other functions, that sort of thing. So here's what we're going to do. Instead of, I will change this a plus h though. I like to color code if I can. So x is this entire a plus h. We don't know what that is, but we also don't know what x was. X was a placeholder. A plus h is just a different way to write an unknown number. So we'll do a plus h, and we group it in parentheses to say we're treating this all as one value. So that's squared. X was squared, so the entire a plus h is squared. Then we'll do minus 3 times, and again, times all of a plus h. And then finally at the end, we'll do plus 5. And now we could be done here. We did it. We plug a plus h in. Because a plus h, we don't know the value of it, there's no way that this sort of works its way out into just a single value like the one up above did. And that is, so evaluating doesn't necessarily mean that you end up with a number at the end. Evaluating really is just means plug in and find out what happens. Plug the necessary or provided value in and find the resultant value. I mean, that's what evaluate means. It just means find the value of. So we could leave it here. This is that plugged in, and because these don't have values, we can't really, we don't know what a plus h squared is. We don't know what 3 times a plus h is. We can do a little bit of stuff here, though, to combine some like terms. So one thing we're going to do, we're going to remember what squaring something means. It means that thing times itself. You might be tempted to distribute this squared in, but you can't do that when this is addition, right? You have to remember something squared means it times itself. And when we do that, well, it'll become hopefully a little bit more clear how we actually go about multiplying that and actually squaring it. Over here, we will take this entire -3 and we'll multiply it here and we'll multiply it there. We'll distribute it. So -3 times a is minus 3a. -3 times h is -3h. And then finally, we have plus 5 at the end. Now here, when we multiply this, remember what we do. We have to take this and multiply, oops, let's do some colors here. Multiply it against each other term. And then we'll also do, so once we've done the a to both of these, we also need to multiply the h to both of them. And so a times a is a squared. That's just what squared means. A times h is ah, or a times h. H times a is ha, or I'm going to write it as ah to show that we have 2 of them. Remember, the order of multiplication doesn't matter. And then h times h is h squared. And then we still have our minus 3a. We still have our minus 3h plus 5. Actually, you know what? We don't actually have any like terms here. Well, we do. We can combine these two. So this is an AH, this is an AH. Doesn't matter if there's 2 variables, right? A plus A is 2A, H plus H is 2H. So AH plus AH is 2AH. So this will be A squared. Then I'm going to write the H squared just to have the squared terms together. Then we have 2 AHs, so 2AH minus 3A minus 3H plus 5. So this is not really much better than this. I would argue this is potentially also a correct answer. But that's what it means to evaluate. This process, actually, of being able to plug in some sort of smaller, this a plus h is a function, right? It's one value combined with another value, to give us yet a resultant value. seeing how a function treats this and how it works itself all the way through and being able to carry it all the way through, that is ultimately an important skill for calculus. So that's why they have this as a practice problem. But there we go. There's our evaluation. Let's actually see what because they had to do one with the A plus H. So let's go back to the textbook. And let's see what they did. Theirs was 3x squared. Oh, wow. They did. Yep. They plugged it in, right? There's the A plus H and it's being squared. A plus H is times 2. And it's also the squared is times 3. And then they went ahead, A plus H squared. They didn't show the steps there, but they showed that's A squared plus 2AH plus H squared, just like we got. And they showed the 3 out front. Then they distributed the 3. Yeah. So they did actually spell it all the way out. Very good. Okay. And ultimately that's useful. It's you want to be able to plug it in and just have that skill of feeling comfortable plugging it in, but really you need to be able to then manipulate it afterwards as well. Okay, cool. What are we sharing? We're sharing the textbook, it looks like. Very good. So there's the checkpoint. Actually, are there answers to the checkpoints? Sorry, I'm scrolling way through to see at the end of this section. These are exercises. Okay. The odd ones you can click on. Oh, there is an answer key. Okay. Checkpoints. Excellent. Okay, there are solutions. All of the checkpoints have solutions, and then it looks like all of the odd exercise problems have solutions. So maybe I just do the even exercise problems. That would be useful. That's a thing that where that's the gap, right? So with that in mind, can I click this and go back? Huh? I can. Well, is it going to scroll me down to it? Oh, it is. Cool. Okay. So what I will do. Once I start using some sort of streaming software, I think that's going to make switching the screen I'm presenting and stuff easier. I think it might also make it. Yeah. So hopefully that's not terribly jarring when I switch screens. All right, so these are section 1 exercises. So this is sort of my plan is just label the things and I'll have the instructions. Is that terribly small? There we go. That's a little bit bigger. Um, and then I can go in and actually copy the problem. Okay. Excellent. Okay, for the following exercises, so there's a part A and a part B. First, we need to determine the domain and range um, of each relation and state whether the relation is a function. Okay. So, first of all, um, I want to boop boop. There we go. This is a um. Here we go. We'll just line this up so it's all one table. Eh, I was gonna do that, but I don't think it's worth it. There we go. Okay. So part A. All right. So domain and range. So we will remind ourselves what domain and range are. Domain is the input or x values for which we'll say relation is defined. So I'm being I'm being really specific with my math language here. It's just the x values. What x values are part of a function? What x values have corresponding y values? So another way to say this is which x values have corresponding y values. And there's a specific notation we use for writing this. We use an interval notation. Range then is the output or y values. Uh, the set, we will say, of output or y values for a relation. And again, we can define it similarly here. This kind of seems like circular logic, but it's not actually. Uh, so it's which y values have corresponding x values. Boom. Um, it, these two questions here, which y values and which x values have a partner. That's actually because if an x value doesn't have a if there an x value can't be part of the domain if it doesn't have a corresponding y value, and a y value can't be part of the range if it doesn't have a corresponding x value. So this ends up working out. Now, there's another couple of words here: relation and function. You're going to be pretty exclusively working with functions, so you don't really need to understand the difference. What you need to know what a function is. All a relation is just a more generic version, right? So a relation um, is having a set of input values and some way to take those input values and make them match up with some group of output values. That's a relation, and it might sound like a function. The thing with a relation is there's not really any restrictions on how you map those x values onto those y values. A function basically says each x value, each input value can only go to one y value. Now, different x values can go to the same y value, but you can't have a single x value that goes to two different y values. I guess it would go the other way, x and y, right? Um, a single x value sometimes for this function when x is 3, the function is 5, but sometimes it's 7. It doesn't work like that for a function. Now, for a relation, you totally could have that, and that's valid for because a relation is just sort of the generic idea of having one set of numbers considered an input and another set of numbers considered the output, and the fact that you can somehow map between them, come up with some pattern for taking those input values and figuring out and having just some way at all, even if it's just you know steps explained. There doesn't have to be math or like equations to just get to figure out, okay, this x value goes to this y value, this x value goes to this y value. A function is the same thing, except there's some requirements. For any x value that actually gets mapped to a y value that's part of the domain, it can only get mapped to a single y value, and that's it. That's the only requirement. But that makes a whole bunch of difference. Just when you restrict to just that, it gives us some really useful stuff and creates some consistencies and some rules that we can be aware of. So the domain is just the collection of input values. And because this isn't like a continuous, like, the numbers 0 through 9, if you're including all of the numbers, decimals, and fractions and stuff, that would be like a continuous. This is called discrete because we only have -3 and -2 and -1 and 0 and 1 and 2 and 3. It's not implied here that 1.5 is part of this relation. What's implied is there's 7 input values and 7 output values that we can see. So the domain is just those input values. So when we're listing just numbers, we put them in curly braces and we just sort of list them: -3, -2, -1, 0, 1, 2. Boom, that's the domain. The range. Now, the order here doesn't actually matter, so we could just list them in the same order. We could also rearrange them and put them in ascending order like these are, but we may as well just put them in the same order to make matching them up easier. And in fact, I'm actually gonna totally line them up. -2, -8, -1, 0, 1, 8. And now this -2 in a set of numbers, you only if a number repeats, you only put it in there once. You can't have duplicates in a set. So because -2 was already included here, I didn't write it again. Okay, that's our domain and range. Pretty straightforward, not even really any work to show or anything. So now, part B, state whether the relation is a function. So this relation, so if we look at this, there's no repeating x values in the table, which means, and there's no y cell that has more than one value in it, right? So -3 only ever goes to -2. -2, the x value only ever goes to -8, the y value. So because we don't have any repeats in here, this relation is a function because each x value is only associated with one y value. Boom. And that would be the answer there. That's the key. Because here you go. Sorry, I want to fix this. There we go. If we go back up here, if there had been, there wasn't, but if there had been, say, another -2 here, and it said 10, it doesn't matter what it says. He, then what this table is telling us is, whenever you have a -3, it maps onto -2. That's the output. Whenever you have a -2 x value, it maps onto -8. -1 for x gives you -1 for y. So on and so forth. But then we get to -2, and we already know that -2 should go to -8, but now it's telling us -2 goes to 10. So that is not a function. But since that wasn't there and there's no conflict, every single one of these x values, we know exactly which single y value it's going to. So boom, that's a function. Pretty straightforward. That actually takes us to the end of this. Didn't get super far on this, but I'm processing it and trying to think how I want to do this. And I do like it. And I think the thing to focus on is going to be even exercise problems. Because everything else already has some amount of support for solutions. At least students can check their answers. And then of course, if students ever have questions about the odd number ones, like even though the answers are available, if they can't figure out how to get that answer, they still might want to see a solution. So I encourage people to send those in. But for now, this was our process here. Sorry about that. Did calculus? Well, we did some section 1.1 of the calculus textbook. It's not quite to calculus yet. It was mostly just review. Make sure there weren't any questions that came in at the last minute. I do encourage you to send your problems in even at the very last minute. If I do miss last minute problems, I apologize. But I'll try not to. Okay, but it doesn't look like you did. So that was our first night of OpenStax, the OpenStax calculus textbook. I'll be returning to that. That feels like a good thing to spend time on while I'm sitting here doing this. And eventually we'll just sort of settle into it kind of like homework. And I can hopefully sort of model that homework routine that I've been talking about. I'm back tomorrow at 3:30, so the after school time. Students here in Eugene are actually out of school at 2 or 2:30 on Wednesday. So being at 3:30, my hope is that that's late enough that students are actually able to attend, if it's useful to them. And then I'll also be back Thursday for 3:30 to 5. That one is right after school. Um, but yeah, please send in your questions. You don't have to wait till I'm live. You can send your questions in anytime at all. I need to start mentioning that at the top as well. Uh, this was nice, not terrible at all. I hope you all have a really excellent night. I will be back tomorrow at 3:30 to keep answering your math questions. Good night.